It began with a sense of confidence, almost bordering on arrogance. By the dawn of the 20th century, scientists believed they had finally grasped the grand machinery of the universe. The world was seen as a perfect mechanism, running like an immense clock whose every gear could be mapped, measured, and predicted. The elegant equations of Isaac Newton had painted a universe of order and determinism, a cosmos that operated under rules so precise that, in theory, one could calculate the future if only the present were known well enough. It was an age of certainty, and within that certainty lay comfort, the belief that humanity had nearly reached the peak of understanding. But beneath that calm surface, in the invisible depths of the atomic world, something strange was stirring. The late 19th century was a time of tremendous scientific pride. Newtonian physics had explained motion and gravity, Maxwell's equations had unified electricity and magnetism, and classical thermodynamics described the flow of energy with clarity. It seemed there was little left to discover. Lord Kelvin, one of the leading physicists of the time, famously declared that, "There is nothing new to be discovered in physics now." All that remained, he said, were a few minor details to be refined. Yet, within those minor details, the seeds of revolution were already planted. Those seeds began to sprout in the unlikeliest of places, in the study of light and matter at their smallest scales. Experiments on how atoms emitted and absorbed energy refused to fit the old laws. The energy didn't flow continuously as expected. It seemed to come in sudden, discrete bursts, packets that would later be called quanta. Max Planck in 1900 proposed a radical idea. Energy was not infinitely divisible but came in these tiny bundles, each proportional to its frequency. It was a desperate attempt to explain what experiments were showing, and Planck himself thought of it as merely a mathematical trick, not a physical truth. But that trick cracked open the door to a new world, one that would soon swallow all certainty. Then came Einstein in 1905, who took Planck's quanta seriously. He used them to explain the photoelectric effect, the way light could knock electrons off metal surfaces. Light, he argued, behaved not just as a wave but as a stream of particles, photons. It was a shocking claim, one that seemed to defy logic. How could something be both a wave and a particle? The comfortable clarity of Newton's world was beginning to blur. Yet, these early signs of mystery were still treated as exceptions, strange puzzles that might eventually yield to deeper classical explanations. No one yet imagined that the very foundation of physics was trembling. By the 1920s, the tremors grew stronger. Scientists like Bohr, de Broglie, and Schrödinger entered the scene, each uncovering more evidence that the microscopic world obeyed laws utterly unlike the ones governing planets and pendulums. Electrons didn't orbit nuclei like tiny planets around a sun. Instead, they seemed to exist as waves spread out in space, only becoming definite when measured. Even stranger, they could interfere with themselves as if they existed in many places at once. The universe, which once seemed like a polished machine, was starting to look like a symphony of probabilities. And then, in the midst of this intellectual storm, came Werner Heisenberg, young, brilliant, and restless. Born in 1901 in Germany, Heisenberg had grown up in a world still basking in the glow of classical certainty. Yet he was part of a new generation that refused to take the old truths for granted. While others tried to reconcile the contradictions of quantum phenomena with classical intuition, Heisenberg dared to abandon intuition altogether. He wasn't content with trying to imagine what electrons looked like. To him, the true task of physics was not to describe what could never be seen, but to predict what could be measured. In the summer of 1925, while suffering from hay fever on the island of Helgoland, Heisenberg isolated himself to think deeply about the atomic puzzle. Surrounded by the sea's endless rhythm and the wind's silence, he began to reconstruct physics from the ground up. He focused purely on observable quantities, the frequencies and intensities of light emitted by atoms, rather than on unseen orbits. Through sleepless nights and feverish calculations, he developed a new mathematical framework that described atomic behavior without ever referencing the invisible paths of particles. This framework would later be recognized as matrix mechanics, the first true formulation of quantum mechanics. It was a revolutionary approach, abstract, complex, and counterintuitive. But within it lay the birth of a profound truth: the world at its most fundamental level was not certain. The equations that governed it didn't tell where an electron is, but only the likelihood of where it might be. Heisenberg's breakthrough marked a turning point, the birth of uncertainty as a scientific principle. It shattered the last illusions of the clockwork universe and replaced them with a reality woven from probability and chance. This idea didn't arise out of confusion or failure, but from deep necessity. Experiments had shown that when physicists tried to measure both the position and velocity of an electron, the results refused to align neatly. The more accurately one was measured, the less clear the other became. It was as if nature itself resisted being pinned down, as if the universe had built uncertainty into its very fabric. This wasn't a flaw in human instruments or a limit of technology, it was a fundamental feature of reality. Heisenberg would later formalize this revelation in his uncertainty principle, but even before that, the birth of this idea was already changing everything science thought it knew. The implications were staggering. If position and momentum could never both be known exactly, then determinism, the idea that the future could be predicted with perfect knowledge of the present, was no longer valid. For centuries, science had been guided by the dream of Laplace's demon, the mythical intelligence that, if it knew the position and motion of every particle in the universe, could foresee all that was to come. Heisenberg's discovery killed that dream. The demon was blind, not because of ignorance, but because nature itself was unknowable in that way. In the world before Heisenberg, certainty was synonymous with truth. Now, truth had become probabilistic. The universe, once envisioned as a smooth, predictable continuum, was instead a tapestry of fluctuations and mysteries. Heisenberg's uncertainty did not merely introduce a new law, it redefined what a scientific law could mean. No longer did physics describe absolute outcomes, it described possibilities, tendencies, and patterns of probability. As word of Heisenberg's new approach spread, it bewildered even the greatest minds of the time. Niels Bohr, one of the architects of quantum theory, recognized its brilliance immediately and became Heisenberg's greatest supporter. Together, they refined the interpretation of this new physics into what became known as the Copenhagen interpretation, a philosophical framework that suggested that reality itself only takes definite form when observed. Until then, particles existed in a cloud of potentialities. Observation was not a passive act but a creative one, collapsing the haze of possibilities into a single outcome. The observer and the observed were now intertwined in ways classical science had never imagined. But the world was not ready to accept this. Even Einstein, the master of relativity, could not bear the loss of determinism. Heisenberg's uncertainty challenged the very heart of scientific faith, the faith that the universe is knowable, and that every effect has a cause. To Einstein, this was intolerable. God does not play dice with the universe, he famously declared. Yet Heisenberg and Bohr replied, "Perhaps it is not for us to tell God how to run the universe." This tension marked one of the greatest philosophical divides in the history of science. On one side stood those who still sought hidden certainty, hidden variables that might one day restore predictability. On the other stood the quantum pioneers who accepted uncertainty not as ignorance, but as truth itself. For them, Heisenberg's principle was not a defeat but a liberation, a doorway to a deeper, more mysterious reality that defied the rigid molds of classical thought. The birth of uncertainty was, in truth, the birth of modern physics. It opened paths that would lead to quantum mechanics, quantum field theory, and ultimately to the technologies that power our modern world, from transistors and lasers to the very computers that shape our lives. But at its core, it was not just a scientific revolution. It was a transformation in the way humanity understood existence itself. It told us that nature was not a static machine, but a living, dynamic dance of probabilities. That observation and reality were bound together in an intimate cosmic dialogue. That at the heart of matter itself there was mystery. And yet, Heisenberg's uncertainty was not chaos. It was order of a new kind, a subtler, more profound order than classical minds had ever conceived. It spoke of a universe that could never be fully known, yet could still be beautifully described through mathematics. A universe that balanced randomness and structure, unpredictability and pattern. In the hum of atoms, in the flicker of photons, in the invisible dance of electrons, there lay an exquisite harmony. A harmony built upon uncertainty. As the scientific world slowly began to embrace this new reality, the old worldviews began to crumble. Physicists who had grown up under Newton's laws struggled to comprehend it. Journalists wrote of weird physics and the end of certainty. Philosophers pondered whether science had abandoned its soul. But those who understood saw something far greater. The unfolding of a deeper truth, one that reflected not just the nature of matter, but the limits of human perception. The birth of uncertainty was not the death of knowledge, it was its evolution. Heisenberg's insight marked the moment when science grew humble. When it looked into the quantum abyss and admitted that some mysteries cannot be eliminated, only embraced, it was a reminder that the universe is not obligated to make sense to the human mind. It will reveal itself only in fragments, through symbols, probabilities, and paradoxes. But in those fragments lies the poetry of reality itself, the rhythm of creation at its most fundamental level. Part A ends here. The world stands on the brink of transformation. Certainty has fallen, and a new vision of nature is about to rise, one that sees beauty in unpredictability and truth in uncertainty. Heisenberg has opened the door, and through it, we glimpse the strange, wondrous landscape of the quantum world, a world where reality itself begins to shimmer. The dawn that followed Heisenberg's revelation was both brilliant and bewildering. Across the world, scientists awakened to a universe that no longer obeyed the familiar rhythm of certainty. The dream of a perfectly predictable cosmos had dissolved into mist, replaced by a strange, invisible architecture made not of solid matter, but of possibilities. It was as if the universe had been speaking in a language humanity never understood, and now, for the first time, the symbols of that hidden grammar were beginning to emerge. Yet, the more physicists translated, the more mysterious the message became. In the years that followed, the scientific community found itself divided between comfort and confusion. Many older scientists, raised on the smooth precision of Newton's equations, could not believe that nature itself might be fundamentally uncertain. They searched desperately for hidden variables, unseen mechanisms that would restore the old order. But every attempt met the same quiet refusal from reality. The atom, the very foundation of matter, seemed to whisper back that certainty was an illusion. Heisenberg himself felt both pride and unease. His principle had revealed a profound truth, yet it also carried a haunting philosophical weight. It forced science to confront a question it had long avoided. What does it mean to know something? For centuries, observation had been the key to knowledge. To see was to understand. But in the quantum world, to see was to disturb, to change, to limit. Every act of measurement became an act of creation. The observer and the observed were entangled in a delicate, inseparable dance. This new vision of reality demanded new mathematics, new logic, even a new philosophy. Niels Bohr, Heisenberg's mentor and collaborator, argued that the paradoxes of quantum mechanics were not flaws to be fixed, but windows into the true nature of existence. Bohr's deep insight was that language itself was inadequate for describing the atomic realm. Words like particle and wave, position, and momentum were human inventions meant for the macroscopic world. At the quantum level, these opposites could coexist in ways that defied common sense. Complementarity, Bohr called it. The idea that seemingly contradictory descriptions were both necessary to grasp the whole truth. Heisenberg's uncertainty principle became the mathematical heart of this philosophy. It wasn't merely a limitation on measurement, it was a statement about nature's identity. The position of an electron was not hidden somewhere waiting to be discovered. It simply did not exist in a definite state until an observation defined it. This was the universe stripped of classical realism, a universe in which reality was not fixed but fluid, shaped by interaction, shimmering between potential and actuality. As this new worldview spread, it found both allies and adversaries among the giants of science. Schrödinger, whose wave equation described how particles evolve, was troubled by the implications. To him, the idea that observation created reality seemed absurd. His famous thought experiment, "The cat both alive and dead until observed," was meant as a critique of the Copenhagen interpretation, not an endorsement. Yet, over time, it became a symbol of the very strangeness Schrödinger sought to expose. The cat in the box became a metaphor for the quantum condition, a reality suspended between possibilities until consciousness intervenes. Einstein's resistance ran even deeper. He admired Heisenberg's intellect, but refused to accept the randomness at the core of quantum theory. For Einstein, the universe was orderly, guided by hidden laws that humans had yet to uncover. "God does not play dice," he said again and again, and each time, Bohr replied with calm conviction, "Stop telling God what to do." Their debates in the halls of Copenhagen and Solvay became legendary. Two titans wrestling not just with equations, but with the nature of truth itself. In those debates, Heisenberg stood quietly but firmly by Bohr's side. To him, uncertainty was not chaos, it was harmony beyond comprehension. It was the realization that precision and predictability were human illusions, convenient tools that broke down when confronted with the true subtleties of nature. He saw beauty in this limitation, a poetic order hidden behind randomness. The uncertainty principle became not just a law of physics, but a philosophy of humility. It reminded humankind that knowledge is always incomplete, that reality is deeper than any equation can reach. As experimental evidence piled up, Heisenberg's ideas found solid ground. Spectral lines, electron diffraction patterns, and the outcomes of double-slit experiments all confirmed the probabilistic predictions of quantum mechanics. Nature seemed to obey the mathematics of uncertainty perfectly. Each measurement revealed that the smallest components of reality behaved exactly as the principle described, never fixed, always fluctuating. It was no longer just theory, it was the pulse of existence itself. In lecture halls and laboratories, a new generation of scientists began to embrace this revolution. Young minds like Dirac, Pauli, and Feynman would later build upon Heisenberg's work, weaving uncertainty into the very fabric of modern physics. Out of these ideas emerged technologies that would change civilization: semiconductors, lasers, quantum computers, and medical imaging. Yet behind every innovation lay the same quiet truth, that certainty is an illusion born of scale, and that beneath the surface of all things lies a world governed by probabilities. But beyond the laboratories, the implications of Heisenberg's discovery rippled outward into philosophy, art, and even human psychology. Writers and thinkers saw in quantum uncertainty a mirror of the human condition, the unpredictability of thought, the fluidity of perception, the limits of understanding. The deterministic world of the Victorian age gave way to the modern world, where ambiguity and relativity defined the new intellectual landscape. The age of black and white truths was ending, shades of gray were now the color of reality. Heisenberg himself often reflected on the philosophical depth of his discovery. He once said that the first sip from the glass of natural science makes one an atheist, but at the bottom of the glass, God is waiting. By this, he meant that science, when pursued deeply enough, leads not to arrogance but to wonder, a recognition that the universe is far more mysterious and profound than human logic can encompass. His uncertainty principle was not just a scientific statement, but a spiritual awakening, a bridge between knowledge and mystery, reason and awe. The years moved forward and the world changed. The rise of quantum mechanics coincided with the turbulence of the 20th century, war, technology, and the dawning atomic age. Heisenberg's name became linked, however controversially, with the development of nuclear physics, and with it came a heavy moral burden. The same principles that revealed the beauty of atomic structure also unlocked destructive power beyond imagination. Yet even in the shadow of those consequences, the essence of his discovery remained pure, a testament to curiosity, not conquest. In time, the philosophical meaning of uncertainty deepened. It became clear that Heisenberg's principle extended far beyond electrons and photons. It was a metaphor for knowledge itself, a recognition that observation always changes what is observed, that truth is shaped by context. Even in human affairs, in economics, in psychology, in every field that studies complex systems, echoes of the uncertainty principle can be found. The act of inquiry influences the outcome, perception alters reality. Through all these echoes, one realization stands out: uncertainty is not a barrier to understanding, but the source of it. Without limits, knowledge would have no direction. It is the tension between what can be known and what cannot that drives discovery forward. Heisenberg's insight gave science not an ending, but an eternal horizon. It invited humankind to explore without expecting absolute answers, to find beauty not in control but in curiosity. Today, nearly a century after that sleepless summer on Helgoland, the world still lives within the shadow and the light of Heisenberg's revelation. Quantum physics has expanded into quantum field theory and quantum information science, each carrying uncertainty as its central pulse. The uncertainty principle remains unchallenged, tested billions of times and never broken. It has become as fundamental as the speed of light or the law of gravity, a constant reminder that at the heart of reality lies mystery. And yet, far from diminishing science, this mystery has become its strength. The acceptance of uncertainty has made science more dynamic, more adaptable, more human. It has taught physicists to speak not in absolutes but in probabilities, not in certainties but in confidence levels. Every discovery now carries within it a measure of doubt, a humble acknowledgement that the story of the universe is still being written. In classrooms around the world, students learn about Heisenberg's principle not as a limitation, but as a revelation. They learn that the atom is not a solid sphere, but a shimmering cloud of possibilities, that light is both wave and particle, that the very act of looking changes what is seen. Each new generation discovers what Heisenberg himself discovered, that knowledge begins where certainty ends. As we stand today, on the threshold of the quantum age, an age of quantum computers, quantum communication, and quantum cryptography, the spirit of Heisenberg's idea continues to guide us. The technologies that promise to redefine civilization are built upon the foundation of uncertainty. The randomness once feared has become a tool for precision beyond imagination. The principle that shattered classical certainty now powers the most advanced frontiers of human progress. Yet the deeper lesson remains the same. The universe is not a machine of gears and levers, but a living, breathing field of probabilities. We are not outside observers looking into a clockwork world, we are participants in an unfolding reality, our choices and observations woven into the cosmic fabric itself. The birth of uncertainty was, in truth, the moment humanity took its first step into the deeper mystery of existence. Werner Heisenberg may have begun his journey seeking clarity, but what he found was something far more profound. A new kind of vision, one that accepts the unknown as part of truth. His principle stands not only as a cornerstone of quantum physics, but as a symbol of intellectual courage, the willingness to face the limits of understanding and still keep asking questions. The universe, it seems, is not a riddle to be solved once and for all, but a story to be continually explored. Every measurement, every experiment, every observation adds a new verse to that story, and yet the ending always remains just out of reach. That is the poetry of uncertainty, endless, alive and ever changing. So, when we look back at the birth of uncertainty in physics, we are not merely recalling a scientific discovery. We are remembering a transformation of the human spirit, the moment when science learned to live with doubt and still move forward with wonder. It was the moment when the light of knowledge met the shadow of mystery, and instead of retreating, humanity stepped boldly into the twilight, guided by the faint but enduring glow of understanding. From that moment on, physics would never again be about certainties. It would be about questions, about probabilities, about glimpses of truth flickering in the dark. And in that flickering light, we find the essence of Heisenberg's legacy, the eternal reminder that the closer we come to knowing the universe, the more we must embrace its beautiful uncertainty. He was not just a scientist, he was a dreamer in pursuit of nature's hidden rhythm. Werner Heisenberg's mind was unlike any other, sharp as a blade, yet poetic in its curiosity. To understand his vision is to travel into the heart of a generation that was rewriting the laws of reality. The world he inherited was one of precision and certainty, but the world he would leave behind was one of probabilities and paradoxes, a place where the observer and the observed shared an unbreakable bond. Heisenberg's journey was not just about equations, it was about perception, imagination, and the courage to question the foundations of knowledge itself. From the beginning, Heisenberg stood apart. Born in 1901 in Würzburg, Germany, he grew up in a time when science was worshipped almost like a religion. The universe, as taught in schools and universities, was a masterpiece of order. Everything from the motion of planets to the ticking of clocks could be described with mathematical elegance. But Heisenberg's curiosity was never content with what could be seen. As a boy, he would gaze at the stars and wonder not only where they were, but what they were made of, what secret rules guided their glow. His fascination with patterns, with symmetry, with invisible harmony, shaped him long before he ever set foot in a laboratory. Heisenberg's education coincided with the golden era of German physics, a time when giants like Einstein, Planck, and Sommerfeld were transforming the landscape of thought. Under Arnold Sommerfeld's mentorship in Munich, Heisenberg quickly revealed his brilliance. He had an extraordinary ability to see the deeper logic hidden within the chaos of data. To him, physics was not about mechanical repetition or memorization. It was about intuition, about glimpsing the invisible. Sommerfeld once said that Heisenberg possessed a kind of inner sight, an instinct for truth that could not be taught. That instinct would soon lead him to the frontier of the unknown. But brilliance alone was not enough. The world Heisenberg entered as a young physicist was divided and uncertain. The old rules of classical mechanics were failing to explain new discoveries at the atomic scale. Electrons did not behave like tiny planets circling a nucleus. They danced unpredictably, leaping between energy levels in ways no one could explain. The physics community was in crisis, torn between the comfort of classical ideas and the chaos of new experiments. It was a world desperate for a new vision, and Heisenberg was destined to provide it. He had something rare, a mind that could move between logic and intuition, mathematics and philosophy. Where others tried to visualize the atom as a miniature solar system, Heisenberg stripped the problem of imagery entirely. He believed that what truly mattered were not unseen orbits but measurable quantities, the frequencies and intensities of light emitted by atoms. He asked a radical question: what if physics stopped trying to imagine what electrons are and focused instead on what we can actually observe? It was a bold rejection of centuries of tradition, but it was also the seed of a revolution. In 1925, Heisenberg's vision reached its defining moment. Exhausted and suffering from hay fever, he retreated to the small, windswept island of Helgoland in the North Sea. There, far from lectures, colleagues, and distractions, he wrestled with the mystery of atomic behavior. His nights were restless, the air filled with salt, the silence broken only by the cry of seabirds and the distant roar of waves. He carried notebooks filled with scribbled equations, diagrams, and ideas that refused to settle. And then, one night, as the stars shimmered above the dark sea, the breakthrough came. He realized that he could describe atomic transitions, not by imagining electrons moving along orbits, but by using arrays of numbers that represented observable quantities, what he later called matrices. Each element of these matrices captured the probability of an atom shifting from one energy state to another. It was a leap into pure abstraction, a mathematics that had no physical picture but described reality with astonishing precision. That night, Heisenberg had crossed a threshold no one else had dared to approach. He had invented matrix mechanics, the first true form of quantum mechanics. This was not just a scientific achievement, it was an act of intellectual rebellion. It meant that the fundamental reality of the universe could not be visualized in human terms. The atom was no longer a miniature machine, it was a symphony of mathematical relationships. Nature, Heisenberg discovered, spoke a language not of certainty but of probability, and his mathematics was the first to truly understand its grammar. When Heisenberg returned to his colleagues, they were astonished. Even Niels Bohr, the guiding philosopher of quantum theory, was struck by the audacity of Heisenberg's vision. The equations worked, but they defied intuition. In Heisenberg's world, the motion of an electron could not be described as a clear trajectory. It existed only as a set of potential outcomes. For many physicists, this was deeply unsettling. Yet for Heisenberg, it was liberation. He had freed physics from the prison of classical imagination. He once said, "I believe that the path to scientific progress lies in the courage to discard the old picture of reality when it fails." That courage defined him. He was not afraid of the unknown, he was fascinated by it. To Heisenberg, uncertainty was not ignorance, it was a gateway to understanding. The unknown was not a void to be feared, but a horizon to be explored. His visionary mind saw harmony in the very places others saw contradiction. And it wasn't just mathematics that drove him. Heisenberg was also a philosopher at heart. He read Plato, Goethe, and Kant, drawing inspiration from the idea that nature could be both rational and mysterious. He saw the atom not merely as a physical object, but as a reflection of deeper order, a manifestation of balance and tension, much like music. In fact, Heisenberg often compared quantum mechanics to a symphony. Just as music arises from the interplay of notes, harmony, and timing, the physical world, he believed, emerged from the interplay of probabilities and measurements. To him, mathematics was not cold or mechanical, it was alive, a language of creation. This blending of science and philosophy made Heisenberg unique among his peers. While others sought rigid explanations, he sought meaning. He wanted to understand not just how the universe worked, but what it meant that it worked this way. When he developed his famous uncertainty principle 2 years later, it wasn't simply an equation, it was a statement about existence. Heisenberg's mind was able to bridge the physical and the metaphysical, to see science not as a collection of facts, but as a dialogue with reality. The true measure of Heisenberg's visionary genius lay in how he could embrace contradiction without fear. In a world where science had long worshipped clarity, he accepted ambiguity as truth. He understood that knowledge does not always mean knowing everything, but knowing where the limits of knowing lie. His uncertainty principle was born from this realization, a recognition that the universe, at its deepest level, resists complete precision. The more you try to know one aspect, the less you can know another. It was as if nature itself demanded humility from those who sought to uncover its secrets. In every way, Heisenberg's mind embodied this humility. Despite his towering intellect, he remained aware of the boundaries between what can be measured and what can only be imagined. When others debated whether the atom was real or just a mathematical construct, Heisenberg would quietly remind them that the purpose of science was not to define reality, but to describe experience. He believed that physics should concern itself with what can be observed and predicted, not with metaphysical speculation about unseen worlds. This was not a retreat from mystery, but a respect for it. Heisenberg's approach fundamentally changed the purpose of science. Before him, physics sought certainty, to find the one true model of how nature worked. After him, physics sought understanding, to find the best possible description of how nature behaves when we observe it. This shift may seem subtle, but it changed everything. It redefined truth itself as something dynamic, something that exists within the relationship between observer and reality. It was, in a sense, the birth of modern thought. The more Heisenberg's ideas spread, the clearer it became that his was not just a scientist's vision, but a poet's. He could see beauty in abstraction, harmony in paradox. His equations, though complex, were elegant, each symbol a window into nature's secret music. He once compared his experience on Helgoland to a mystical revelation, describing how, as he gazed at the sea, the problems of physics began to dissolve, replaced by a sense of unity. A feeling that the mathematical order of the atom was connected to the rhythm of the universe itself. That moment defined him forever. It was not just the birth of a new physics, it was the birth of a new way of seeing. Heisenberg's mind became a bridge between reason and imagination, between science and philosophy, between certainty and wonder. Through him, physics transcended the laboratory and entered the realm of thought, art, and spirituality. He had turned the study of matter into a meditation on existence itself. And yet, his vision did not come without struggle. The abstractness of his ideas alienated some of his contemporaries. Many could not grasp how something invisible and intangible could be treated as real. They demanded pictures, mechanical models, or simple explanations. But Heisenberg refused to dilute his truth for the sake of comfort. He insisted that nature is not obliged to conform to human expectations. The atoms, he once said, are not things. They are patterns, probabilities, interactions, something far subtler than solid matter. To think otherwise was to misunderstand the very essence of the quantum world. Part A ends here. At the height of Heisenberg's breakthrough, when his visionary mind had shattered the walls of classical thought and opened a new horizon for humanity, the old world of mechanical certainty had fallen away, and in its place stood a universe shimmering with possibility. A universe that could finally be understood only through the eyes of imagination and intellect combined. In the soft light of history's turning point, the figure of Werner Heisenberg begins to emerge with striking clarity, not as a mythical genius, but as a real human being shaped by the restless energies of his time. His life was a delicate balance between brilliance and doubt, between the security of established knowledge and the uncharted sea of the unknown. As the world around him shifted under the weight of war, politics, and scientific revolution, Heisenberg's mind sought patterns that lay hidden beneath the chaos, laws that could explain not only how nature behaved, but why it behaved so mysteriously. His journey was not one of comfort, it was one of struggle, conflict, and ultimately, revelation. From his early years, Heisenberg carried within him a sense of wonder, a burning desire to uncover what lay beneath the visible world. He was drawn to the mysteries of light and matter, not through curiosity alone, but through an instinctive feeling that reality was far deeper than appearances suggested. He found joy not in certainty, but in exploration. His teachers, especially the legendary Niels Bohr, recognized that his mind worked differently. He was not satisfied with what could be seen or measured. He wanted to know what could not be seen, what defied classical reasoning. When Heisenberg arrived at the University of Copenhagen to work with Bohr, the two formed one of the most extraordinary partnerships in the history of science. Their discussions often stretched deep into the night, filled with intensity and philosophical wonder. They debated endlessly, not about numbers and equations alone, but about meaning itself. What does it mean to say something exists in the quantum world? Is observation passive, or does it shape reality itself? These were not idle questions. For Heisenberg, they were the essence of understanding. Heisenberg's visionary mind was restless, constantly at war with itself. He found himself trapped between two worlds, the old, familiar physics that treated atoms as miniature planets orbiting a sun, and the emerging quantum picture that defied logic altogether. He worked tirelessly to find order within this chaos. The mathematics he developed were not just tools, they were attempts to describe a reality that no human eye could witness. His equations spoke a new language, one where uncertainty was not an obstacle, but an inherent feature of the universe. Yet even as his ideas began to take shape, Heisenberg was plagued by doubt. What he was proposing seemed too radical, too unsettling. For centuries, physics had been the domain of predictability. Every cause had an effect, every motion followed a rule. But Heisenberg's mind whispered a different truth. Perhaps at the smallest scales, nature was not obedient. Perhaps it was free. The thought thrilled and terrified him at the same time. His visionary strength lay not just in his intellect, but in his courage to accept mystery as truth. In the summer of 1925, while suffering from hay fever, Heisenberg isolated himself on the remote island of Helgoland, surrounded by sea winds and silence. There, away from the distractions of the world, he experienced a moment that would redefine science forever. As he walked along the rocky coast, his mind raced through patterns of energy, light, and matter. He realized that instead of trying to describe the invisible motions of electrons, something no one could ever see, he could describe only what could be observed, the frequencies and intensities of the light they emitted. That night, as the waves crashed against the shore, Heisenberg found the breakthrough he had been seeking. In a feverish burst of insight, he wrote down a new formulation of quantum mechanics that abandoned the idea of particles moving in fixed orbits. Instead, it treated their behavior as a set of abstract relationships, a mathematics of probability rather than certainty. In that moment, the universe changed. This was the birth of matrix mechanics, a mathematical revolution that shattered the old view of physics. It was not about where an electron was, but about the likelihood of finding it somewhere. Heisenberg's equations described not physical objects, but the structure of possibilities. The atom was no longer a miniature solar system. It was a symphony of potential outcomes. What Heisenberg had discovered was more than a scientific method, it was a new philosophy of nature. When he shared his work with Bohr and Max Born, their reactions were electric. Born, who immediately recognized the importance of Heisenberg's approach, gave it a formal mathematical framework. Bohr, though cautious, saw in it the seeds of a profound new understanding. Together, they realized that Heisenberg's vision had unveiled something astonishing, that the world at its core was not deterministic, but probabilistic. The laws of physics were no longer about certainty, they were about the likelihood of events. But this revelation came with a cost. To many of his contemporaries, the idea that reality itself could be uncertain was deeply unsettling. Einstein, in particular, found it intolerable. God does not play dice with the universe, he famously remarked. Yet Heisenberg stood his ground. He believed that the universe was not governed by human comfort or expectation. Nature was as it was, mysterious, unpredictable, and wondrous. To deny that uncertainty existed was to deny truth itself. Heisenberg's visionary mind was not limited to equations or laboratory results. He was a philosopher at heart. His work reflected a deep belief that science and philosophy were intertwined, that to understand the universe, one must also confront the limits of human thought. He often spoke of the beauty in uncertainty, the elegance of nature's hidden order. To him, the atom was not chaos but poetry, a dance between what can be known and what forever remains unseen. His quantum vision extended beyond science. It offered a metaphor for life itself. Just as an electron exists in a cloud of probabilities, so too do human choices and possibilities. We live not in a world of absolutes, but in a realm of potential. Heisenberg's insight suggested that the future is not predetermined. It is created through observation, through interaction, through choice. Every act of understanding changes what is understood, yet behind his revolutionary ideas, Heisenberg remained deeply human, modest, introspective, and often burdened by the weight of his discovery. The uncertainty that he described in physics also lived within him. He was haunted by the implications of his work, especially as the scientific world moved toward the atomic age. His principle, born from curiosity, would one day influence technologies that could both heal and destroy. It was a paradox he never fully reconciled, but one that reflected the duality of knowledge itself, light and shadow, creation and danger. Still, despite the controversies, Heisenberg's visionary brilliance could not be denied. He had looked into the deepest heart of matter and found not chaos, but a new kind of order. His genius lay not in providing answers, but in asking the right questions. Questions that continue to echo across physics, philosophy, and human thought. By the time the full impact of his work was recognized, the world had already begun to change. Quantum mechanics had become the foundation of modern science, shaping chemistry, electronics, and even the way we think about consciousness. And at the center of this transformation stood a man who, through doubt and imagination, had seen what no one else could, that certainty is an illusion, and that the universe, in its infinite complexity, speaks in the language of uncertainty. Werner Heisenberg's visionary mind will forever stand as a symbol of intellectual courage. He did not fear mystery, he embraced it. He did not cling to what was known, he reached for what was unknowable. His revolution was not just scientific, but spiritual, a reminder that the boundaries of knowledge are also the gateways to wonder. In the end, Heisenberg's greatest gift to humanity was not a formula, but a perspective that to seek truth is to accept uncertainty, and that within the unknown lies the true beauty of existence. In the quiet corridors of scientific history, few moments have echoed as profoundly as the one when Werner Heisenberg put pen to paper and revealed an idea that would transform the very foundations of reality. It was not a discovery born of chance, nor a sudden spark of imagination, but the result of years of restless questioning, sleepless nights, and a relentless pursuit of truth that refused to conform to human logic. The year was 1927. The world was still reeling from the effects of the Great War, nations were rebuilding, and the scientific community stood at a precipice. Classical physics, the proud creation of Newton, Maxwell, and Einstein, had reached a point where it could no longer explain the behavior of the smallest particles in the universe. Something deeper was at play, something strange and invisible, and into this mystery stepped a young man with a mind sharp enough to cut through centuries of certainty. Werner Heisenberg was no longer the student seeking guidance. By this time, he had already shaken the scientific world with his new approach to quantum mechanics, a system that abandoned the visual comfort of orbits and replaced them with abstract mathematical structures. But something still troubled him. Despite the elegance of his equations, there remained a question that refused to be silenced. How much could we truly know about a particle? Scientists had long assumed that, given enough precision, they could measure anything, the exact position of an atom, its speed, its future path. The universe, they believed, was a perfect clockwork machine. Yet Heisenberg had seen the cracks forming in this belief. The deeper one peered into the quantum world, the more elusive it became. It was as if nature itself hid behind a veil, revealing just enough to hint at its presence, but never enough to be fully known. The path to the uncertainty principle was not a single revelation, but a gradual awakening. Heisenberg began to notice that in quantum experiments, the very act of measurement seemed to disturb what was being measured. When physicists used light to detect an electron, the energy from that light altered the electron's motion. The more accurately they tried to pinpoint its position, the more its momentum shifted beyond control. The closer they came to clarity, the deeper they fell into ambiguity. This wasn't an error of technology or human imperfection. It was a law of nature. It was as though the universe was whispering knowledge has limits. In the spring of 1927, Heisenberg gathered his thoughts into a concise mathematical form. He expressed it not as a philosophical idea, but as a precise relation, a boundary between what could and could not be known. Simple, elegant, and revolutionary. It stated that the product of the uncertainty in position lex and the uncertainty in momentum Zaplov could never be smaller than a fixed constant. The more one knows about where a particle is, the less one can know about how fast it is moving. This was not a flaw in human measurement, it was an inherent truth about the universe. Nature itself, at the most fundamental level, was uncertain. For centuries, physics had been built upon the belief that every effect had a cause, every motion a reason, and every event a predictable outcome. Heisenberg shattered that illusion with one equation. The uncertainty principle marked a turning point, not just in physics, but in the philosophy of knowledge. The cosmos was no longer a clock ticking in perfect order. It was a sea of probabilities, a dance of chance and necessity. At first, the reaction from the scientific community was mixed. Some saw the beauty of Heisenberg's discovery, its honesty, its depth, its courage to accept the limits of human understanding. Others, however, found it deeply unsettling. For those who had built their lives on the certainty of Newtonian laws, this was nothing short of heresy. How could a universe governed by mathematical precision suddenly tolerate uncertainty? How could science, built on the foundation of measurement and control, admit that certain truths could never be known? Niels Bohr, Heisenberg's mentor and intellectual companion, immediately grasped the magnitude of this revelation. To Bohr, the uncertainty principle was not a failure of physics but a triumph, a reflection of nature's subtle harmony. Heisenberg's insight confirmed what Bohr had long suspected, that the observer could never be fully separated from the observed. The act of observation itself was an interaction, an exchange, a dialogue between matter and consciousness. What we see in the quantum world is not an objective picture of reality, but the outcome of an interaction shaped by our presence. For Heisenberg, this realization carried a quiet beauty. It meant that science was not merely about collecting facts, but about understanding relationships. The universe was not a frozen mechanism, it was alive with possibilities. Every observation changed the landscape of what could be known. The electron, the photon, the atom, all existed not as fixed entities but as probabilities in motion. Their reality was not absolute, it was conditional, shaped by the act of inquiry itself. The more Heisenberg thought about his principle, the deeper its meaning became. It was not only a statement about measurement, but about existence. At the smallest scales of matter, certainty dissolved. There was no such thing as a precise path, no fixed trajectory, no predetermined outcome. The universe, in its very fabric, was built upon uncertainty. But rather than seeing this as chaos, Heisenberg saw it as freedom. The atoms that made up everything, stars, planets, and life itself, were not bound by rigid determinism. They were governed by possibility. This new vision of the cosmos changed everything. It forced physicists to abandon their old way of thinking and adopt a probabilistic view of nature. Instead of predicting exact outcomes, they now calculated the likelihood of events. In place of certainties came probabilities, and with them a new understanding of reality, one that was both humbling and profound. Heisenberg's uncertainty principle also carried profound philosophical weight. It challenged the very definition of knowledge. For centuries, human progress had been measured by how much we could explain, how much we could predict. But Heisenberg showed that there were boundaries that could not be crossed, not because of ignorance, but because of the nature of existence itself. The idea that reality could exist without absolute precision was a shock to the scientific mind. It suggested that the ultimate truth might forever lie beyond human reach. Yet within this uncertainty lay a new kind of wisdom. Heisenberg's work reminded humanity that to seek understanding is not to conquer nature, but to coexist with it. His principle revealed that the more deeply we probe the universe, the more we must respect its mysteries. Science was no longer about domination, it was about dialogue, a conversation with the unknown. Even Einstein, whose theories had revolutionized physics just a few decades earlier, struggled with this new worldview. The idea that randomness could play a role in the universe was deeply troubling to him. He believed in an underlying order, a cosmic logic that governed all things. God does not play dice, he famously said in response to Heisenberg's principle. But Heisenberg replied with quiet conviction that perhaps the universe was not playing dice at all. Perhaps it was we who misunderstood the game. Over time, the evidence grew undeniable. Experiments confirmed that Heisenberg's principle was not a philosophical abstraction, but a measurable truth. The more precisely scientists tried to locate a particle, the more unpredictable its motion became. Quantum mechanics, built upon this uncertainty, began to explain phenomena that classical physics could not. From the structure of atoms to the behavior of light, the new science worked, not in spite of uncertainty, but because of it. Heisenberg's discovery did not end the quest for knowledge, it redefined it. The uncertainty principle became a cornerstone of quantum theory, shaping everything from the behavior of subatomic particles to the design of modern technology. Without it, there would be no quantum computers, no semiconductors, no lasers, the very tools that power our modern world. Yet beyond its practical achievements, the principle carried a deeper truth, that the boundaries of knowledge are not barriers, but invitations to wonder. As Heisenberg reflected on his discovery, he often spoke about the balance between knowledge and humility. He believed that uncertainty was not an obstacle to science, but its guiding light. To know that something cannot be known completely is, paradoxically, a form of wisdom. It is an acknowledgement of our place in the grand tapestry of the universe, small, curious, yet capable of glimpsing the infinite through the cracks of uncertainty. The uncertainty principle was not just a law of physics, it was a statement about existence itself. It revealed that beneath the surface of order lies an ocean of possibilities, each wave carrying the potential for creation and change. Heisenberg had shown that the universe is not a static machine, but a living, breathing system of chance and connection. In its uncertainty, it finds its beauty. Heisenberg's legacy would go on to influence not only scientists but philosophers, artists, and thinkers across disciplines. His principle became a metaphor for the human condition, the idea that life, like quantum mechanics, is uncertain and unpredictable. Yet it is within that uncertainty that meaning is found, within that ambiguity that creativity flourishes. In the years following his discovery, Heisenberg would look back on the moment of insight with quiet awe. He understood that he had not merely written an equation, he had opened a window into the soul of nature. Through that window, humanity glimpsed a truth both humbling and liberating, that certainty is an illusion and that the universe, in all its mystery, thrives in the space between what is known and what is unknowable. The story of the uncertainty principle does not end with its discovery, it begins there. When Heisenberg unveiled his idea to the scientific world, it was like lighting a torch in a darkened hall. The flame illuminated more than he had expected. Suddenly, the entire structure of physics, centuries of logic and precision, began to tremble under its light. The world of certainty, the universe of perfect predictability imagined by Newton, no longer stood unchallenged, and yet, rather than bringing chaos, Heisenberg's discovery revealed a deeper, more subtle order, one that lay beneath the surface of apparent randomness, one that accepted the mystery of nature instead of denying it. Heisenberg knew from the beginning that his principle would not be easily accepted. He was, after all, questioning the very foundation of scientific measurement. How could a physicist, whose purpose was to measure and calculate, admit that certain things were fundamentally immeasurable? Yet this was exactly what his mathematics revealed. The uncertainty principle was not a matter of faulty instruments or experimental error. It was an unavoidable law, an intrinsic property of the quantum world itself. The particles that made up the universe were not objects in the ordinary sense. They were waves of possibility, existing everywhere and nowhere, their behavior describable only in terms of probabilities. As Heisenberg presented his findings, he was met with a blend of admiration and resistance. Some physicists saw in his principle the missing piece that explained decades of confusing results. Others saw a threat, a challenge to the very meaning of science. They asked, How can we call something a law of nature if it refuses to yield precise answers? Heisenberg's response was simple yet profound. Science is not about forcing nature into certainty, it is about describing nature as it truly is. And nature, at its most fundamental level, is uncertain. This idea transformed the very language of physics. Before Heisenberg, physicists spoke in absolutes: velocity, position, energy. All could, in theory, be measured exactly. After Heisenberg, they began to speak of ranges, probabilities, and likelihoods. The universe, once viewed as a deterministic clock, became a symphony of possibilities. No longer could one say with confidence that an electron is here or is there. Instead, one had to say it might be here, could be there, or is likely to be found somewhere in between. The reality of the quantum world was no longer definite, it was statistical. To some, this shift was terrifying. To others, it was beautiful. The uncertainty principle was not the end of understanding, but the beginning of a new kind of wisdom. One that embraced complexity instead of simplifying it away. Heisenberg himself found solace in the elegance of this truth. He realized that uncertainty was not disorder. It was the signature of an underlying harmony that human perception could barely grasp. Like a piece of music that could not be captured in a single note, reality was composed of overlapping probabilities that together created the melody of existence. As experiments confirmed his ideas, Heisenberg's work became the cornerstone of the emerging field of quantum mechanics. It provided the framework through which scientists could predict the behavior of particles, not with perfect precision, but with astonishing accuracy. It was paradoxical. By accepting uncertainty, physicists had found a more reliable way to describe reality. This new science explained why atoms behaved as they did, why light could act as both wave and particle, and why the universe, in its smallest parts, seemed to shimmer between being and becoming. But Heisenberg's revelation went far beyond equations. It touched the heart of human thought itself. For centuries, philosophy had drawn a line between what could be known and what could not. Heisenberg erased that line. He showed that the limits of knowledge were not philosophical boundaries, but physical ones, woven into the fabric of reality. Even if humanity built the most powerful tools imaginable, there would always remain an uncertainty that could never be overcome. This realization humbled science and elevated it at the same time. It transformed knowledge from an illusion of control into an act of wonder. In the quiet hours of reflection, Heisenberg often pondered the philosophical meaning of his principle. What did it mean that the universe itself was uncertain? Was reality an objective structure, or did it depend on the observer's presence? The line between perception and truth began to blur. It seemed that by simply observing the universe, humans were changing it, not metaphorically, but literally. Every measurement, every experiment, every act of observation altered what was being observed. The observer and the observed were inseparable. This idea struck at the heart of Western thought, which had long placed human consciousness outside of nature, looking inward from a distance. Heisenberg's principle dissolved that boundary. Humanity was not a detached spectator, but a participant in the unfolding of reality. The universe was not a stage upon which events played out independently. It was a living system that responded to observation, intertwined with awareness itself. As word of Heisenberg's work spread, the philosophical ripples reached far beyond physics. Poets, artists, and thinkers began to draw inspiration from this strange new view of the world. To them, uncertainty was not just a scientific law but a metaphor for existence. Life, too, they realized, is uncertain. Every choice, every possibility, every unseen future mirrors the behavior of the quantum world. The same laws that govern the invisible particles also govern the flow of time, the paths we take, and the dreams we pursue. Heisenberg had given humanity a mirror, one that reflected not only the structure of matter, but the nature of life itself. In those years, the debates between Heisenberg and Einstein grew legendary. Einstein's mind refused to accept the notion that reality could be governed by chance. He sought a deeper, hidden order beneath the probabilities. But Heisenberg remained steadfast. To him, uncertainty was not chaos but completeness, a way of acknowledging that nature does not owe humanity total transparency. It was a profound act of intellectual humility. Heisenberg often said that physics should not dictate how nature must behave, but should instead listen to how nature does behave. This perspective revealed the poetic side of Heisenberg's genius. He was not just a scientist but a philosopher, a thinker who could see beauty in limitation. To him, the uncertainty principle was an invitation to approach the universe with reverence. Every atom, every quantum of light, every flicker of energy was part of a grand, interconnected mystery. The limits of knowledge were not walls to break through, but windows through which one could glimpse the infinite. As quantum mechanics matured, the implications of Heisenberg's principle became ever more profound. It laid the foundation for technologies that would reshape human civilization. The semiconductors in computers, the transistors in communication devices, the medical imaging systems that peer inside the human body, all owe their existence to the principles Heisenberg revealed. His equation, once scribbled in solitude, became the blueprint for the modern world. Yet, despite its power, the uncertainty principle retained its philosophical essence, a reminder that progress and mystery can coexist. Even as his fame grew, Heisenberg remained humble. He understood that his principle was not the final word but a doorway. Beyond it lay realms still unseen, quantum fields, virtual particles, and strange entanglements that connected distant points in space and time. The deeper scientists probed, the more astonishing the quantum world became. But through it all, the core of Heisenberg's message endured. The closer we get to truth, the more we encounter mystery. In his later years, Heisenberg often reflected on the paradoxes that had defined his life. He had sought certainty and found uncertainty. He had searched for clarity and discovered that clarity itself had limits. Yet he considered this not a defeat but a triumph. To him, the uncertainty principle was a gift, one that freed science from arrogance and restored to it a sense of wonder. It reminded humanity that the pursuit of knowledge is not about possessing truth, but about dancing with it. The moment Heisenberg wrote his equation in 1927, he unknowingly changed the very meaning of science. From that point onward, physics would no longer chase the illusion of perfect prediction. Instead, it would seek to understand the probabilities that define existence. The world became richer, more intricate, more alive. And in that new vision, the human spirit found its reflection, uncertain, yet endlessly curious. As the decades passed, and as technology advanced to realms Heisenberg could scarcely have imagined, his principle continued to guide the way. Even today, every time a physicist peers into the heart of an atom or a quantum computer processes information through superposition, Heisenberg's insight lives on. His discovery remains both a scientific law and a philosophical compass, reminding us that reality is not a rigid chain of causes and effects, but a dynamic, breathing fabric woven with chance and potential. The formulation of the uncertainty principle was more than the birth of a new theory, it was the awakening of human thought. It taught the world that knowledge and mystery are not enemies, but partners, that the unknown is not to be feared, but embraced. Heisenberg gave us more than an equation. He gave us a vision of the universe that is humble, profound, and beautifully unfinished. And so, in the grand story of science, his legacy endures, not as a monument of certainty, but as a living reminder that even in the smallest particles of matter, the spirit of mystery is alive. The uncertainty principle whispers to us through every flicker of light, every atom of existence, every choice we make. It reminds us that life itself, in all its unpredictability, is a reflection of the same truth Heisenberg saw in the quantum world, that uncertainty is not the end of understanding, but the very beginning of it. In the quiet aftermath of Heisenberg's discovery, the scientific world stood at a crossroads. For centuries, physics had been built on the foundation of certainty, a belief that if one could measure everything, one could predict everything. Newton's laws had made the universe seem like a grand machine, every motion predetermined, every effect born from a clear cause. But Heisenberg's uncertainty principle shattered that illusion. It was as if a veil had been lifted, revealing that beneath the surface of predictability lay a world ruled not by certainty, but by chance. The classical framework that had guided human understanding since the age of Galileo began to tremble under the weight of this new revelation. When Heisenberg introduced his idea, it did more than challenge old theories. It challenged the very way scientists thought about reality. The idea that the universe was no longer entirely knowable was a profound blow to the human desire for control. Many physicists resisted it. Einstein, in particular, could not accept a world governed by probabilities. His famous words, "God does not play dice with the universe," captured his discomfort with Heisenberg's new physics. But others, like Niels Bohr, saw in this uncertainty not chaos, but a deeper order, an order that could only be understood by embracing the limitations of observation itself. As experiments in quantum mechanics grew more precise, the evidence began to side with Heisenberg. The microscopic realm, electrons, photons, atoms, refused to obey the rigid predictability of classical laws. Instead, it behaved according to probabilities, where outcomes could only be described in terms of likelihood, not certainty. The more one tried to pin down a particle's position, the more its momentum seemed to blur. This strange duality became the heartbeat of a new physics, one that saw nature not as a machine, but as a mysterious dance of possibilities. This shift was more than scientific, it was philosophical. It forced humanity to reconsider its place in the cosmos. For centuries, scientists had viewed themselves as detached observers, separate from the phenomena they studied. But quantum physics suggested that observation itself changes reality. The act of measuring, of simply looking, could alter the outcome. The observer and the observed were no longer independent, they were intertwined in a delicate web of interaction. The uncertainty principle didn't just shake the pillars of physics, it reshaped the foundation of human thought. It taught scientists that knowledge is not absolute, that nature keeps some of its secrets hidden, no matter how hard we try to uncover them. This realization sparked debates not just in laboratories, but in philosophy, art, and even theology. Suddenly, the universe seemed far less mechanical and far more alive, unpredictable, dynamic, and deeply interconnected. The shattering of classical physics gave birth to an entirely new scientific vision. The deterministic world of Newton had served its purpose, guiding the industrial age and the mechanical understanding of motion and matter. But in the atomic and subatomic world, those laws no longer applied. The new world demanded new rules, and quantum mechanics provided them. What once seemed impossible, teleportation, superposition, entanglement, now emerged as natural consequences of this uncertain reality. In the end, the collapse of classical certainty was not a loss, but an awakening. It revealed that the universe is richer and more complex than human minds can fully comprehend. Heisenberg's principle did not destroy order, it redefined it. It taught us that true understanding begins not with absolute answers, but with the humility to accept uncertainty. From that humility, science was reborn, not weaker, but wiser, aware that the beauty of the cosmos lies not in its predictability, but in its endless mystery. Behind the equations and theories that shaped the quantum revolution stood a young man burdened by both brilliance and doubt. Werner Heisenberg, a physicist whose discovery redefined reality, but also tested the boundaries of his own humanity. The story of Heisenberg is not merely one of intellect, but of courage, the courage to challenge centuries of scientific belief and to embrace a truth that even he found unsettling. The human side of his discovery reveals a portrait of a thinker who wrestled not only with the mysteries of nature, but also with the weight of his own insight. Heisenberg's journey began in a world recovering from war and confusion. Europe was scared, and so was science. Yet within this chaos, young minds sought meaning through reason. Heisenberg was one of them, restless, determined, and deeply curious. From an early age, he displayed a fascination with the hidden order behind things, the patterns that governed both the stars above and the atoms below. His teachers saw in him a spark that refused to settle for surface answers. To Heisenberg, science was not a profession, it was a quest for truth. When he first encountered quantum ideas under the guidance of Niels Bohr, his mind was open to a new way of thinking. But this path was not easy. The equations made sense, yet the implications felt disturbing. The more he explored the behavior of particles, the more he realized that the universe was not as stable or predictable as he had believed. Each experiment seemed to whisper a paradox, that knowledge itself had limits. Heisenberg struggled with this realization late into the night, often pacing his room, rewriting equations, and questioning his own logic. Those who knew him described him as a man both calm and restless, a thinker caught between precision and wonder. His uncertainty principle, born from sleepless nights and endless debate, was not just a mathematical breakthrough, it was an emotional one. It required humility, the ability to admit that nature would not reveal all her secrets, no matter how deeply one probed. This was a radical act of honesty, and it cost him. Many older physicists dismissed his ideas as incomplete or even wrong. Yet Heisenberg held his ground, not out of arrogance, but out of conviction. He trusted what his calculations showed, even if his heart still wrestled with their meaning. But Heisenberg was not a man lost in abstractions. He was aware that his work touched something deeply human, our desire to know, to predict, to control. In challenging that desire, he forced science to confront its own limits. He reminded the world that even in an age of reason, mystery has its rightful place. His interactions with colleagues like Bohr revealed his humility and his struggle. Their debates often went beyond science, touching on philosophy, faith, and the nature of truth itself. Behind every formula lay a question that no mathematics could answer: what does it mean to know? Heisenberg's discovery came at a time when humanity was racing toward a new technological age. The implications of quantum mechanics would soon shape inventions, politics, and even war. Yet for Heisenberg, the principle of uncertainty was not about power, it was about wisdom. He saw in it a warning that knowledge without humility could lead to destruction. His later years, marked by reflection and controversy, showed a man deeply aware of the moral weight that science carries. He understood that the pursuit of truth must always walk hand in hand with the responsibility of its use. Through all his achievements, Heisenberg remained a deeply introspective figure, a scientist with the soul of a philosopher. His discovery was not just an intellectual milestone, it was a mirror reflecting humanity's eternal struggle between knowing and believing, between control and wonder. He taught that uncertainty is not a weakness, but a doorway to deeper understanding. In the silence of his study, amidst papers filled with symbols and probabilities, Heisenberg found not chaos, but beauty. The beauty of a universe that keeps its secrets not to frustrate us, but to invite us to keep searching. The human side of Heisenberg's discovery is a reminder that science is not built by equations alone. It is built by hearts and minds willing to question everything, even themselves. His journey shows that true genius lies not in finding all the answers, but in having the courage to live with the unknown. And in that courage, Werner Heisenberg found not just uncertainty, but truth. The quantum revolution that began with Heisenberg's uncertainty principle did not remain confined to the chalkboards of physicists or the pages of scientific journals. It rippled outward, transforming the very foundations of human civilization. What started as a strange idea about invisible particles soon became a force that reshaped the world. The revolution in quantum physics changed not only how we understand the universe, but also how we live within it. It marked a turning point where human knowledge, once limited by the visible, expanded into the unseen. From the laboratories of the 1920s to the technology-driven society of today, Heisenberg's revelation ignited a global transformation that continues to define modern life. In the early days, few could have imagined how deeply this theory would influence the world. Quantum mechanics was strange, counterintuitive, and often incomprehensible even to those who worked on it. Yet it worked. The mathematics predicted outcomes with astonishing accuracy. As experiments confirmed its truth, scientists began to realize that this was not just a new theory. It was a new reality. The understanding that particles could exist in multiple states, that observation could alter outcomes, and that probabilities ruled the smallest scales of nature laid the groundwork for technologies that would later define the modern era. The development of quantum theory led directly to inventions that changed the course of human progress. Without it, there would be no transistors, and without transistors, no computers, no smartphones, no digital world. The lasers that read our disks, the MRI machines that peer into our bodies, the GPS satellites that guide our journeys, all are the children of quantum mechanics. It is remarkable to think that the uncertainty that once disturbed physicists became the foundation of the most precise technologies humanity has ever created. Heisenberg's abstract principle evolved into a practical revolution, quietly powering the heartbeat of the modern world. But the impact was not purely technological. Quantum mechanics also altered the philosophical landscape. It forced thinkers to reimagine reality itself. The deterministic universe of Newton had given humanity comfort, a sense that everything could be predicted and explained. Quantum mechanics replaced that comfort with wonder, uncertainty, and humility. It showed that the universe was far more mysterious and fluid than anyone had imagined. This new worldview seeped into art, literature. It inspired movements that celebrated ambiguity, creativity, and possibility. In a sense, quantum physics became not just a science but a metaphor for modern life. A reminder that reality is not fixed, but ever changing. On a global scale, this revolution unified science in unprecedented ways. Across nations and cultures, physicists worked together to explore the quantum world. The discoveries of one country became the shared inheritance of all humanity. Even during times of conflict and division, scientific collaboration continued to thrive, driven by the universal quest to understand the unseen. Heisenberg's principle had opened not just a door to new knowledge, but a bridge between minds across the world. Yet the revolution also carried shadows. The same understanding of the atomic and subatomic world that brought progress also unleashed the most destructive weapon humanity had ever known: the atomic bomb. The irony of the quantum revolution was stark. The same equations that explained the beauty of the universe could also unravel it. Scientists, including Heisenberg himself, grappled with the moral consequences of their discoveries. It was a haunting reminder that knowledge alone is not wisdom, and that every breakthrough carries responsibility. Despite this, the quantum revolution ultimately deepened humanity's relationship with the cosmos. It showed that even in uncertainty, there is order. Even in chaos, there is meaning. The randomness that once frightened scientists became a symbol of life's richness and complexity. The universe was no longer a rigid machine, but a living system of possibilities. And in those possibilities lay the essence of creation itself. Today, the influence of quantum physics extends into realms that Heisenberg could scarcely have imagined. Quantum computing, quantum communication, and quantum energy research are shaping the future once again. We now stand at the threshold of another transformation, one born from the same principles that shook science a century ago. The revolution continues, evolving from equations into experiences, from theory into technology, from uncertainty into understanding. Heisenberg's quantum revolution was not just about particles or probabilities, it was about perception. It redefined how humanity sees the universe and its place within it. The world became not a static entity to be measured and controlled, but a living mystery to be explored. The uncertainty that once seemed like a limitation became the key to progress, creativity, and connection. Through this revolution, science did not lose its direction. It found its soul. The legacy of Heisenberg's uncertainty principle is one that stretches far beyond the walls of laboratories or the pages of textbooks. It is a legacy that changed how humanity thinks about knowledge, truth, and the very structure of reality. When Heisenberg first introduced his principle, he could not have imagined the vast ripple it would send through time, influencing not only science but also philosophy, art, and our understanding of existence itself. The uncertainty that once challenged physicists became a symbol of intellectual freedom and humility, teaching generations that not everything in the universe can be captured, predicted, or controlled. It was the birth of a new way of thinking, one that accepts mystery as part of truth. As decades passed, Heisenberg's idea became the foundation upon which modern physics was built. Quantum mechanics grew from a controversial theory into one of the most successful scientific frameworks ever created. Every test, every experiment, every discovery reaffirmed the strange yet profound truth that nature does not operate under absolute certainty. The smallest particles of the universe, electrons, photons, quarks, move according to probabilities, not fixed paths. Yet out of this uncertainty arises the stable, beautiful world we live in. The paradox of Heisenberg's legacy is that uncertainty itself creates order, randomness creates structure, and imperfection is what allows the universe to exist as it does. This realization reshaped not only scientific research but also human philosophy. Thinkers and writers began to see Heisenberg's principle as more than a scientific law. It became a metaphor for life. Just as one cannot predict both the position and motion of a particle, one cannot control every outcome in existence. The principle revealed a deep truth about the human condition that life, like the quantum world, thrives in unpredictability. Artists began to capture this spirit through abstraction and fluidity, philosophers used it to question the limits of reason, and educators began to see uncertainty not as failure, but as the birthplace of discovery. In the modern age, Heisenberg's legacy continues to expand. His work paved the way for quantum technologies that define our era, from computers that think in quantum states to communication systems that are virtually unbreakable. But beyond these inventions lies something greater, a change in mindset. The uncertainty principle taught humanity to look at the universe not as a puzzle to be conquered, but as a wonder to be understood. It inspired scientists to think beyond boundaries, to accept paradoxes, and to see that truth can exist in many forms at once. This shift in perception is perhaps Heisenberg's most enduring contribution, the courage to embrace the unknown. On a deeper level, his legacy reminds us that science and spirituality are not as separate as they seem. Both seek to understand the unseen, both grapple with mystery, and both remind us of our smallness within the vast cosmos. Heisenberg's work bridged this gap, showing that uncertainty does not weaken science, it enriches it. It invites us to approach nature not with arrogance, but with awe. In the shimmering probabilities of the quantum world, we glimpse something profoundly human, our eternal desire to explore, to question, and to find meaning amid the unknown. The principle that once seemed to unsettle science has now become its guiding light. Every generation of physicists that follows Heisenberg builds upon his idea, pushing further into the strange frontier of quantum reality. Each new discovery, from quantum entanglement to particle-wave duality, echoes the same message: that uncertainty is not the enemy of knowledge, it is the essence of it. By accepting that there are limits to what we can know, we open the door to what we might yet discover. And so, Heisenberg's legacy lives on, not just in equations, but in thought, in imagination, in the way we see the universe. His principle continues to whisper a quiet truth to every seeker of knowledge that certainty is an illusion, and that the real beauty of science lies in its endless questions. The moment science became uncertain was not a moment of defeat, but of awakening. Through that uncertainty, humanity learned to see the universe anew, not as a fixed design, but as a living symphony of possibilities. And in that endless interplay of chance and order, of mystery and discovery, the spirit of Werner Heisenberg continues to guide us, reminding us that the quest for truth will always begin and end in wonder.